All right, guys, today we're going to talk about scatter plots, which we are talking about because they have what we call lines of fit, which fits in nicely with our lines unit. And it's also kind of a nice segue because after our lines unit, we'll start talking about statistics, which scatter plots are a part of statistics. So first, we're just going to talk about what is a scatter plot, how do you interpret it. So scatter plots are relating two different sets of data. So here we're talking about smoothies, and we're talking about the amount of sugar versus the amount of calories in a smoothie. So each point is a different type of smoothie, and you're plotting how many grams of sugar and how many calories to get that coordinate. Here it says the scatter plot shows the amount in grams of sugar and the numbers of calories in 10 different smoothies. So that's why there are 10 different points. How many calories are in the smoothie? That contains 56 grams of sugar. So along the bottom here, 56 would be this point. And if I go straight across, that'd be 270 calories. Then it says how many grams of sugar are in a smoothie that contains 320 calories. So here's my calories. I go straight across, that's this point. Straight down would be 70 grams of sugar. What tends to happen to the number of calories as the number of grams in sugar increases? So if we kind of look from left to right, we're going up. So if sugar is increasing, that means calories increase as well. So if it's going up from left to right, they're both increasing. If it was going down, if it was negative, you would say as sugar increases, calories decrease. So the first one will always be increasing, whatever your x term is, and then the y-axis label will be increasing if it's positive or decreasing if it's negative. So there are three different relationships, or what we call correlations, for scatter plots. So here it says a correlation is a relationship between the data sets. You can use a scatter plot to describe the correlation between data. And I should have mentioned this earlier, but I'm sure I mentioned it in class. I did post all of these graphs for you as a PDF. So if you want to annotate on top of them in something like Kami, you can, or you can print them out if you want to copy and paste them, cut and paste them into your notebook, anything like that. So these are examples of our correlations. And there are not graphs for these. You just want to put a quick sketch of what these look like in your notes. It says a correlation is a relationship between data sets. You can use a scatter plot to describe the correlation between data. So positive is when it goes up from left to right as x increases, y increases. This one is negative. It's going down from left to right as x increases, y decreases, and we're always reading from left to right, just like we would read a sentence from left to right. No correlation is when there's no pattern. Everything just kind of all over the place. All right, so I replaced it with nice type text, so that's a little easier to read. So positive is up from left to right, negative is down from left to right, no correlation is all over the place. You can't seem to find a pattern. So you just want a quick sketch for this page. Both of these graphs are posted on that PDF I mentioned, so just FYI. Here it says identifying correlations. Tell whether the data shows a positive, a negative, or no correlation. So age and vehicles owned. So this is how old a person is and how many vehicles they've owned up until that point in their life. And if you ask me, this is kind of all over the place. Like I can't for sure say it's going up or for sure say it's going down. So I'm going to say that this has no correlation. This one, it's pretty clear that this is going down from left to right. As I go to the right, as the average daily temperature increases, the coats sold goes down, which should make sense because I am sure very few people are buying a coat when it's 70 degrees outside, right? They're mostly buying them in the winter where it's freezing. So this would be a negative correlation. Easy peasy. And then last one for today, we are going to draw the scatter plot ourselves, and then we're going to draw in what we call a line of fit. And when we draw them in by hand, they're just called lines of good fit. Tomorrow we'll talk about what a line of best fit is. This one says the table shows the weekly sales of a DVD and the number of weeks since its release. Write an equation that models the DVD sales as a function of the number of weeks since its release. Interpret the slope and y-intercept of the line of fit. So I'm going to start by plotting my points here. So I need a point at 119. I need one at 215, 313, 411, 510, 68, 77, and 85. And it looks like I'm missing a grid line here, so let me put that in. Should be one running right through there. Okay, so a line of good fit. You want your line that you're going to draw in by hand here to go through your data where about half the points are above and about half the points are below. So let's kind of experiment here. So it looks a little too steep. I'm just going to try to manipulate my line so that it goes through the middle as best as I think possible. And honestly, I think that looks pretty good. It's pretty even through the middle. I have some above, some below. I might be able to move it a little bit lower. Maybe that looks better. But you're just trying to, you can't connect all the points perfectly because they're not in a straight line, but we can draw a straight line that kind of models what's happening here. So then it says, write an equation that models this. So we're going to write an equation for the line we drew in. So if I look, here I have a point at 0.19, or I'm estimating that that's where it's at. And it looks like it's going right through this point here too, which is at 510. So I'll use those 2 points to write my equation. So if I do 19 minus 10, that gives me 9. 0 minus 5 gives me negative 5. So my slope is negative 9/5, and my intercept is 19. So my equation is negative 9/5 x plus 19. Then the last part says interpret the slope and y-intercept of my line of fit. So we want to talk about what's happening here. So we're saying slope is always y over x, change in y over change in x. So in this case that would be sales over weeks. So we're losing about, let me go ahead and type this for us. For our slope, we are losing, since it's negative, we're losing $9 million every 5 weeks of DVD sales. And then y-intercept means that we started at 19 million in sales. At 0 weeks, we had 19 million in sales. Okay, so you're just kind of putting it back in context. So y was how many millions of dollars I was making each week. So this was down 9 every 5 weeks. And we started at 19 million. All right, so that's how we would do these types of problems. So that's it for our notes today. You do have a big ideas assignment to work on.